Okay, hello everyone. Welcome to this very random video about recursion with resistors. So we can consider this infinite ladder sequence. And what the question is we want to find the resistance between point A and point B. So the first section, the resistors are only 1 ohm, and then followed by n ohms, and then n squared ohms, then n cubed ohms, and so on and so forth, and it is infinite. So our classical methods of using of solving resistors in parallel and series, they do not work because the tower is infinite. If it was finite, you could work from the back and then solve it all the way down such that you can find the resistance. But no, now it's infinite. So we have to find a new method. So how does this recursion method work? Well, you let the resistance between A and B be a big R first. And then what you do is we consider this highlighted part. And you can see that the highlighted part is just n copies of the original resistance, because 1 times n is n ohms, and then n times n is n squared, n times n squared is n cubed, and so on. So the resistance between point A prime and point B prime, it is just n times R, because it's n copies of R. So there we have it. And then now you can simplify the circuit into something that is really easy to solve. Over here, R would just be equals to this circuit that also includes a function of R in one of its components. So that is new, but it is not difficult to solve. So we use our standard formulas for resistors in series and resistors in parallel. And eventually what you get to is that R is equals to 3 minus 1 over NR plus 1. So you can do more algebra with it, and eventually you get here NR squared plus 1 minus 3n times R minus 2 equals 0. So this is quadratic. And what you can do is you can use a quadratic formula to solve it. So we do that. And you can see that we'll eventually get over here minus 1 over 2n plus 3 over 2 plus minus the square root of 9 over 4 plus 1 over 2n plus 1 over 4n squared. So there is a plus minus sign over here, but we know that the equivalence resistance must be a positive value, and hence we take the positive branch, and this will be our final answer over here. So what we can do now is we can consider what happens as n tends to infinity. So if you think about it intuitively, as n tends towards infinity, there will be no current flowing through the n ohms or n squared ohm branches, because the resistance is simply too huge. So what you'll get is a very simple circuit with only 3 1 ohm resistors connected in series, and so you get 3. And the maths verifies this as n tends towards infinity. All the terms with a denominator of n or n squared tend towards 0. And you can see, yes, indeed, R tends towards 3 ohms as n tends towards infinity. And another thing we can do is we can plot a graph of n against R. So as you can see, the red graph is how R varies with n. As n increases, R also increases, but at a decreasing rate. So you can see the graph dr, the n is decreasing down towards 0. So yes. And there's an asymptote at r equals to 3, which is what we know from the maths and also what we know intuitively. We can see it graphically here also from this decimals plot. So yeah, that's all I have for this video. I don't know whether you guys find this interesting, maybe not, but I just decided to make a video about this anyway. So see you guys in the next video.